This is a short video describing a utility called objdump, which is going to allow us to see information in those object files which I referred to. So every assembler programmer should know about object files. You don't have to know a lot about them to program an assembler, but if you're getting to get deeper into the computing process, or if you're doing cybersecurity stuff, sometimes it's useful to peek into object files to see what's there. So other operating systems besides Linux will have other programs for this purpose, other utilities for this purpose. Objdump is a simple command line utility that works on Linux. Let's just start by looking at our quad-a.asm to see just basic information. And that's the object file, it's not the assembler file. And what does it tell us? It's telling us that quad-a.o is using an ELF32 format for the i86 architecture. It's x86 32-bit architecture. It's telling us it has relocation information, and this is important, and the start address is 0. So what does has relocation information mean? The main point is that when this file was assembled, the assembler didn't know where in memory it was going to go. If I had an instruction in there, and I'll just type one, that's a typical instruction that you did in some of those earlier labs. Outbuff was a chunk of memory in your data section or in your BSS section, and that would get the address of outbuff into the register ESI. So the problem is that when the assembler assembled this program, it didn't know what else was going to be in memory. It didn't know all kinds of things about where the program was going to actually be in memory. So the actual address of outbuff is not there. So it's going to generate an object file where it's going to have information saying, I've got outbuff, it's a label that's going to be in my .text section or my .data section or my .bss section, and it's going to be in there at this place. And when you finally figure out where this program goes in memory, then please put the actual address here. That's called relocation. Has relocation information in it. It's pretty much is telling us the program has been compiled but hasn't been linked yet, and that's going to be useful for linking. Let's just take a look at the same thing for the final program. And here's the same architecture, same file format, and now instead of saying has relocation information, it's telling us it's ready for execution. So if somebody hands you this file and say, I don't know what it is, all right, and you don't want to rely on the .o or .asm because that might be deceptive anyway, right? The objdump program can tell you a lot about it. And notice here that the original start address was 0 because it didn't know where it was. And here the eventual start address is over here. That's where your program's going to start. Notice it's been relocated. Let's take a quick look at the quad driver. My apologies. There we are. And we notice the quad driver main program object file is going to be the same kind of architecture and format. It has relocation address. It also says it starts at 0. Okay, they can't both start at 0, this one and this one. They've been combined, linked into one program. They can't both start at 0, right? So relocation happened. All right. The last thing I want to do is show you a little more deeply the kinds of information you can get out. And we're going to do -x now at quad A. And That's the beginning stuff is the same thing as we saw. And now I'm going to notice that it's got here, it's showing you the actual segments. These are the segments that you've been using in your SASM labs. They're the sort of standard segments for initialized data, for space for uninitialized data with no data in it yet. And .text is, of course, your program. Here's the length of the program, in hex, right? All right, so that's like going to be about 110, right? In decimal. And here are some other segments containing debugging information that the programmer didn't see. We will notice here that we've got some symbols. The symbol -4 is a label inside the data section. The label no real solutions is inside the program, inside the text section. Okay. Quadratic is a label which is the main subroutine entry point, which is in the text section. Okay, like that. So on your code. So that's useful information, and I'm going to show you some other useful information in QuadDriver. And what I'm going to show you down here is, QuadDriver is going to have main and these other things. So here's main, which is the main program in the code. And here is printf. So printf is a subroutine in the C library that it's calling. So which segment is it in? Well, that's undefined at this point. Okay? Quadratic is our subroutine in our assembler file. That's undefined at this point too. So we can see, in addition to the labels inside the program and what segments they're in, we can see the subroutines that are being called, which is a lot of times really useful for figuring out, here's an object file that we don't know what it does. You could run it to find out what it does, and that might not be the best move always if you don't know what that file is, but you can run objdump on it, and you can see things like what it calls in the C library. Okay, what system routines is it calling? Like that. So that is frequently extremely revealing about what the program is doing. Okay, and these relocation records down here are explaining. Okay, when it calls printf, there's a call printf. So somewhere in the assembler for the C program, it's going to say call printf. So that has to have an address. So just like we saw with move esi, outbuff, the call printf has an address there. So it has to put the address after relocation. So, okay. And that call to printf is actually going to get filled in not when the linking happens, but later when the program starts to execute. So it's going to link to that external C library at the moment the program executes. All right, so that's a basic introduction to objdump, useful utility that assembler programs and cybersecurity people want to know about.